Hey guys, so we're going to be starting LT5, which is key features of quadratic graphs. Okay, so we're going to be focusing mostly on this parabola. Okay, so LT5 as a learning target states that I can identify key features of quadratic functions, and that includes the vertex, the x-intercepts, the y-intercepts, the axis of symmetry, domain, and range. And it says increasing and decreasing. We're actually going to cut that part out for this year. So every graph of a quadratic equation is going to take the shape of the parabola, similar to the one shown at the right. So we've spent a lot of time in LT4 talking about transformations, and a big part of that is the parabola. Okay, so we talked about 4 different functions, but this time we're focusing on just the parabola. All right. So here's another example of a parabola, and we're actually going to use this to identify some of those key parts. Okay, so parabolas have many parts. Let's define them and label them below. So what I've done is I actually just kind of created this as a drag. So on our parabola, it's always going to be U-shaped, and we have your graph is going to cross the x-axis. Okay, so this axis here, either 2 times, 1 time, or no times. And if you remember back when we talked about the quadratic formula and the types of solutions, you'll remember we had 3 scenarios. Either there was 2 solutions, there was 1 solution, or there was no solutions. And that exactly corresponds to the number of times that your graph crosses the x-axis. We either had, if the number underneath the square root was positive, we had 2 real answers. If the number underneath the square root was 0, we had 1 real answer. And if the number under the square root was negative, we had no real answers. And again, that completely corresponds to how many times your graph crosses this x-axis. Okay, so those are our x-intercepts. Okay. And then we have another term that you should probably be familiar with, which is your y-intercept. Okay, how many or where does your graph cross this y-axis? And you're only ever going to have one y-intercept. Okay, for a parabola, that's only going to happen once. So this point down here, 0, -8, that's our y-intercept. Okay, and then we have our vertex, something else that we've talked about a couple times now. And our vertex is basically it's either the lowest point, which it would be on this graph, or if my graph is flipped the other way around, it would be the highest point. Okay, we refer to them as a minimum and a maximum, and we'll talk about that in a second. But this lowest point here, -1, -9, that's our vertex. And then finally, we have what's probably a very new term. And if you think about what the term symmetry means, it means it's a line that you can draw, whereas if you were to fold your graph on that line, it would look exactly the same on both sides. So it should make sense that that line would go right through the center of your graph. And the center of your graph also happens to be the vertex. So your axis of symmetry is always going to be a line that goes directly through the vertex. Okay, so that's that one. Now we're going to look at a couple different terms. And some of them you kind of know, but we're going to define them on here either way. So I'm going to change this to a little bit darker color so you guys can see. Okay, so an x-intercept. An x-intercept is defined as the location, I don't want that underlined, sorry. The location where your graph crosses the x-axis. Okay, so on our previous graph, flip back here for just a second, that means at -4, 0 and +2, 0. Okay, those 2 places where your graph crosses the x-axis. All right, and then we have our y-intercept. Very similarly, our y-intercept is defined as the location, and we can even say points. Okay, so we'll change this, we'll add the word points in here. Okay, location, points, y-intercept, same thing. Okay, Y-intercept is the location. In this case, it's just point. It only crosses once. Where the graph crosses the y-axis. Okay. And then vertex. So we just talked about vertex very briefly, and we said that your vertex is it's basically defined as the midpoint of your graph. And we're going to get a little bit more specific here with these next two terms. So more specifically, we have what's referred to as a maximum. Okay, so a maximum is kind of what you'd think, the highest point of the graph. So this would be the vertex if the graph is opening down. And then we have the minimum. Okay, minimum is the lowest point of the graph. And that would be if the vertex, if the graph is opening up. Okay, so that would be, for example, on our previous slide. And this one, our graph is opening up. So that makes this point down here our vertex, which is also a minimum in that case. All right, axis of symmetry. So this is a newer term. Axis of symmetry is a line that we'll make that more specific. It is a vertical line that passes through the vertex. It is always written as x equals, okay, because we're writing it as the equation of a line. And when I write the equation of a vertical line, it's always going to be where it's crossing through that x-axis. So we write it as x equals. In this case, it would be x equals -1. Not coincidentally, it's always also going to be the x coordinate of your vertex. Okay. So we'll put written as x equals. And it's always the x coordinate of the vertex. All right, domain and range. These are terms that you should know, but they are always one of the most challenging aspects of this learning target. So your domain is defined as all the x all the x values that make your function true. Okay, so basically all the x values that are on that line. And then the range, you might be able to either remember or guess, is all the y values that make your function true. And we're going to write these in two different notations. We have either what we call interval notation or inequality notation. Okay, so that just means if you're going to say x is greater than something, y is greater than something, or else we use the terms, the infinities, and we'll add those in a little bit later. Okay, so for example, we have a graph here at the right. Okay, so identify the key features. So our x-intercepts are always, again, wherever your graph crosses your x-axis. So I'm going to use this pen here. And for example, that's one of our x-intercepts. And then this is our other x-intercept. Okay. So I'm going to write those as points. Okay, you're always going to write them as in point form. So that would mean that this one would be -1, 0 and 5, 0. Okay, our y-intercept. So our y-intercept is where our graph crosses our y-axis, which in this case would be right here. Okay, so our y-intercept is going to be 0, -5. All right, our vertex. This is where you're looking for either a point, or I'm sorry, either the highest point or the lowest point. So in this case, because our graph opens up, we don't have a highest point. These keep going, okay? But we do have a lowest point and that is right here. And we're going to write that as that coordinate. So the point that we have here is over 2 and down -9. So 2, -9. And then a minimum or a maximum. Well, we kind of started this one by saying that it has a lowest point, so that is a minimum. Okay. Our axis of symmetry. So axis of symmetry, we said, and we typically write it as a dash line. Axis of symmetry always goes directly through the middle of your graph and your vertex. Okay. The other thing that I pointed out before was that your axis of symmetry, well, two things, is always written as x equals, and it is always equal to the x coordinate of your vertex. So in this case, our vertex was at 2, so that means our equation of our line is that x equals 2. All right, the last thing is domain and range, which are arguably the trickiest parts of this. So domain is all the all the x values that make your equation true. So basically that's saying, and this is where I miss being able to see you guys in the classroom because I use a lot of arm gestures to explain this, but this graph goes on forever and ever and ever to the left. It's going to keep going. And this graph, this side of the graph, goes on forever and ever and ever in this direction to the right. It uses everything. And we're going to have to get a little tricky here with our symbols because I want to make sure you have the right one. Okay. And I'm going to show you this. Thank goodness. I'm going to show you this in the main notation, which I think is what's going to be easiest for you to remember. And see if this is actually going to work for me here. That is to say, we're going to do parentheses. And when we say forever and ever to the left, that means that we are using our infinity symbol, assuming we have an infinity symbol. Here we go. Okay, so to the left is negative infinity, and it goes forever to the right, which means it goes from negative infinity to the left all the way to positive infinity on the right. Where did my symbol go? There we go. Okay, so that's our domain. And the nice thing with domain is that it's always the same for a parabola. Every parabola continues on forever and ever to the left and forever and ever on to the right, no matter what. Even if it's upside down, it goes forever and ever to the left and forever and ever to the right. So domain for parabolas is actually pretty easy. Your range, okay, your range refers to your y values. So your y values go up and down. You always start from the lowest, and your lowest is this lowest point, okay? Your lowest y value is -9. And if I go up, I realize that these points, both sides of my graph go up forever. So I'm going to write my range as this. And we're going to use a bracket this time, okay? And the bracket is because it includes the -9, okay? So -9, okay, that's the lowest point, all the way up to infinity. Okay, and that's how we write that, and we're going to change that to that. Okay, so infinities have to be in parentheses because you can never actually touch infinity. But you can touch, and your graph does touch and go through -9. Okay, so again, -9 to infinity. I don't know if I can change that one anymore. That one might just have to stay black. Okay, so -9 is our lowest point here, all the way up to infinity. Okay, and that is the majority of key features.